In this video, we are going to complete these questions together. Let's start with the first one. In the following sequence of reactions, we have to find the compound D. We have to choose which one is the correct one. So let's start. See here, I have ethyl alcohol, okay, and then phosphorus plus iodine. In this case, I have my ethyl iodide. What is this? Ethyl iodide. Now next, okay, so this is your compound A. Next, this one is made to react with magnesium in the presence of ether. Then we get a Grignard reagent, CH3 CH2 Mgi. This is your Grignard reagent. This is your compound B. And next, we treat this compound B, which is a Grignard reagent, with a formaldehyde, C or H, C double bond O H. Okay, this one. See here, oxygen is more electronegative than carbon. So carbon bears a partial positive charge. Here we have partial negative. This is a metal, so obviously it is partial positive. This is partial negative. Now here, negative part goes to attack this partial positive carbon. The electrons from this bond shift here, and so this positive part comes here, okay, and we have H C O Mgi H CH2 CH3. Now next, what we do? We hydrolyze. This is your compound C. Next, we hydrolyze. When we hydrolyze, then what happened? Here we have OH, here H, CH2, CH3, plus we have MgIOH, okay, or we can write MgOHI. What is this? CH3, CH2, CH2, OH. This is an propyl alcohol, right? So the correct answer, the compound D, this is your compound D. Your compound D is an propyl alcohol. Next, see here, okay, among the following compounds, which can be dehydrated very easily? So you have to choose the correct answer. Here you have to know the stability of carbocation. What do we know? We know that tertiary carbocation, CH3, CH3, CH3. This is your tertiary carbocation. And then here, this is your secondary carbocation, and here this is your what? Primary carbocation. Tertiary carbocation is more stable than secondary than primary. Here you have to know the stability of carbocations. So here, see here, this carbon to which the OH group is attached is further bonded to 3 carbon atoms. So this is tertiary. What about this? 1, 2, secondary. What about this? Primary. And here, this is bonded to this, okay? So this one is a primary carbon atom. So I've told you that the the more stable, okay, the more stable the carbocation, the more easily the alcohol will be dehydrated. So in this case, this is the correct answer. Let me show you here. I have this alcohol. CH2, CH3. Now what we do? We add concentrated sulfuric acid. So from here we have H plus, right? So dehydration happens. That means there is an elimination of water molecule, and here you have a tertiary carbocation. This is your tertiary carbocation. Why? Because this carbon is bonded to how many? 1, 2, 3, right? So that's why this alcohol can be dehydrated very easily because of this. Next, this one. See here. During the dehydration of alcohol to algene by heating with concentrated sulfuric acid, the initiation step is, we have to choose the correct answer. We know that when we have an alcohol, okay, and we heat it with a concentrated sulfuric acid, alcohol, heat with concentrated sulfuric acid, then dehydration takes place and we get an algene, okay, and we want to know the initiation step. So let's take an example of an alcohol, say ethyl alcohol. Ethyl alcohol, heat with concentrated sulfuric acid, then what we have? We have ethene. Alright, now let's check the mechanism. Your first step, from here you will get your proton, okay? So you have alcohol molecule with 2 lone pairs of electrons on oxygen atom, and we have the protonation of ethyl alcohol molecule. So what we have? CH3, CH2, and then OH, H, 1 lone pair with a positive charge. This is your protonated alcohol, okay? Now in the second step, to neutralize the positive charge, these electrons here go to oxygen, okay? And so what do we have? We have a stable carbocation, CH2 plus, okay? This is your carbocation. And next, this carbocation, 1, 2, 3, and then 1, 2 with a positive charge. What do? There should be a loss of proton, okay? So these electrons here form a double bond here so as to neutralize the positive charge, and we have the loss of proton. Here we have H, 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 H. Then we have CH2, double bond, CH2 with a proton. This is ethene. So which one is the initiation step? This one, which is the protonation of alcohol molecule. So the correct answer is the protonation of alcohol molecule. Okay, now we come to this one. See, a hydrocarbon A, we have a hydrocarbon A, it reacts with hydrogen iodide to form a compound B. Now compound B reacts with aqueous potassium hydroxide to give a compound C. Oxidation of this compound C, that means in the presence of an oxidizing agent, gives acetone. This is your acetone, CH3, C double bond O, CH3. You have to write the structural formulas of A, B and C, and also you have to give the equations for all reactions. So how to do this? Let me give you a trick. See here, this is your acetone. The trick or the hint is from here. How many carbon atoms are there here? 1, 2, 3. Okay, 3. So your compound A should be a hydrocarbon which consists of 3 carbon atoms. Now here we don't know whether it is a saturated hydrocarbon or an unsaturated hydrocarbon. Saturated hydrocarbon are alkanes and they are stable, not so reactive. Okay, so here it should be alkene. So CH3, CH, double bond, CH2. How many carbon atoms? 1, 2, 3. Okay. Next, this is your compound A. Okay, your compound A. You treat this one with hydrogen iodide. You want to get compound B. Here you have to follow Markovnikov rule. This is positive, negative. That means the negative part goes to the carbon which is less hydrogenated. And so the electrons from this bond shift here, and the positive to the carbon which is more hydrogenated. Then what do we have? CH3, CH, CH3 and then I. Okay, this is your compound A, this is your compound B. Next, you are adding aqueous potassium hydroxide. Aqueous potassium hydroxide. This group will be replaced by this. So what do you have? CH3, CH, OH, CH3. And next, this is your compound C. You are oxidizing this compound C with an oxidizing agent, say potassium dichromate in acidic medium. Then what happened? You get your acetone. This is a secondary alcohol, and we know that when we oxidize a secondary alcohol, we get what? A ketone, which is acetone. This is your acetone. Okay, so what is your A? Your A is propene, and then your B is 2-iodo 1,2,3 propane. Okay, and then what about your C? Your C is butan 2-ol or 2-butanol. Sorry, 2-propanol, not butanol. Right? Done. We come to the last one. What is that? See here, a compound A. There is a compound A. It reacts with thionyl chloride, SOCl2, to give a compound B. Then B reacts with magnesium, okay, in the presence of ether, to form a Grignard reagent. And then this Grignard reagent is treated with acetone. This is your acetone. And then further you hydrolyze, okay, you get your 2-methyl-2-butanol. 1, 2, 3, 4. 2-methyl this is your 2-methyl-2-butanol. Okay, you have to find out or to write the structural formulas of A and B. So see here, the hint is from here. This compound have how many carbon atoms? 1, 2, 3, 4 and 5. Okay, 5 carbon atoms. And here how many? 1 2 3. So you already have 3 carbon atoms. Then your compound A should have 2 carbon atoms. 2 carbon atoms. And we know that alcohol reacts with thionyl chloride, right? So here it should be ethyl alcohol. So this is your compound A. This one is made to react with thionyl chloride. We want to know what is our compound B, okay? So from here you will have your here HCl, then sulfur dioxide, then ethyl chloride. You get ethyl chloride plus sulfur dioxide plus HCl. Okay, next this is your compound B. Now to this compound B you are adding magnesium. Then you get a Grignard reagent, right? CH3, CH2, MgCl. This is your Grignard reagent. And now next, what you do? You add acetone. Acetone. First you are adding acetone. First step, second step. This is partial positive, partial negative. Partial positive, partial negative. Negative goes to attack to the partial positive carbon, and so these 2 electrons come here, these come here. So now what do we have? CH3C, okay, CH3. Here we have CH2, CH3, and here we have OMgCl. Next you follow second step, which is the hydrolysis. Once you hydrolyze, what do you have? You have this compound OH, CH3, CH2, CH3 plus MgOH, What is this? This is nothing but your CH3, CH3, OH, CH2, CH3, which is our 2-methyl 2-butanol. Okay, what are your A and B? Your A is ethyl alcohol or ethanol, and your B is ethyl chloride. Okay, hence we are done with all the questions.